Finally, let's move on to the last question of the day. Question number 10. How do you evaluate the limit of 1 minus cos x divided by x as x approaches 0? Okay, so if we were to calculate this limit by normally, okay, so as x approaches 0 of 1 minus cos x of x, we get 0 over 0, which is indeterminate, okay? So there is a method of calculating these limits when you have indeterminate form. So another indeterminate form is, I guess, like, so let me just write off indeterminate forms, okay? So we have 0 over 0, we have infinity over infinity, we have 0 to the power of infinity, and so on, okay? So if you guys want to look for the full catalog of all the indeterminate forms, these are basically, we cannot calculate it any further because we don't know what 0 divided by 0 is, or we don't know what infinity is divided by infinity is, okay? So the Hopital's rule is can be used to calculate these kinds of limits. And the only criteria for the Hopital's rules, so the Hopital states that the limit as x approaches a of a quotient of functions is equal to the limit as x approaches a of their respective derivatives, okay? As long as the limit of x approaches a of f prime of x and g prime of x exists, okay? So it has to be a value, all right? So as long as the limit exists, then L'Hopital's rule can be applied, okay? So we're going to solve our question here now. We're going to use L'Hopital's rule. Okay, so we have the limit. That's way too thick. So we have the limit of 1 minus cos of x divided by x as x approaches 0. So if we derive the top, so let's say d of dx of 1 minus cos x. So we know that the derivative of cosine is equal to negative sine, but since it's negative cos, we're going to have sine x. And the d of dx of x is 1. Okay, so now we want to calculate the limit of x approaches 0 of sine x and 1. Okay, which is just equal to limit as x approaches 0 of sine x, and sine of 0 is just 0. So now we have found our limit of this actual function by using L'Hopital's rule. So the limit of 1 minus cos x divided by x as x approaches 0 is 0 using L'Hopital's rule. Okay, so this solution is correct. Okay, so so we realized that 1 minus cos x over x as x approaches 0 is indeterminate. So we use L'Hopital's rule to calculate the limit. So we derived both the top function and the bottom function. So the top function is 1 minus cos x. 1 is a constant, so that's equal to 0 when we derive it. And negative cos x, the derivative of that is just sine x. Okay, so that's the derivative of the top. And the derivative of the bottom is just x. So the derivative of x in terms of x is just 1. So then we just get the limit of sine x as x approaches 0, and sine of 0 is 0. Okay, so we have found our limit of our original function by using L'Hopital's rule. And L'Hopital's rule is very useful in these kind of settings when you cannot calculate the limit using normal conventions like substitution or algebraic methods or using the conjugate or whatever. Okay, cool. So that wraps up our session for today. I hope that you guys learned something, and if any other questions regarding your calculus homework or any kind of questions on the test that you guys were struggling on, please submit them through OneClass, and we'll try to get to them as soon as possible. Thank you so much for listening, and I hope you guys have a good night.